Hello and good day, everyone. My name is Chi Seng, and thank you for attending my Teacher Day Conference talk, where I'll get to share a little bit about my small-scale research study. I titled it Double Trouble because not only the chemistry is really not an easy subject, but then we incorporated, this a lot of calculations, which is basically fundamental mathematics in chemistry, hence the double trouble. So I'm specifically going to talk about the idea of mole ratio. Chemistry teachers would know that the mole is a specifically difficult topic in the context of chemistry. Perhaps you had certain nightmares about it when you were a student if you're no longer doing chemistry or teaching sciences. So I am going to talk about my all-in-one mole ratio method, which I taught the students, and I'll get you to see how effective it has been. Not that it has been super effective, but it is effective to some extent, and I'm going to talk about that in today's talk. So why is it important? So math and science are core subjects. As we know, they are incorporated as part of the PSR and then the SPE, and then the students get to be streamed into the science stream or the art stream. And the science stream students, we tend to look for their ability in math because it's an essential subject that is intertwined together with the natural sciences, the triple sciences. Unfortunately, for a lot of students, chemistry is quite a difficult concept to understand because it's really, really abstract. We have the macroscopic properties, which we can see with our naked eyes. We also have, at the molecular level, the submacroscopic stuff, which we can't see with our eye, not even with the microscope, but almost everyone would know that H2O is basically one of these oxygens and two of these water. But not a lot of people actually know the symbol for the elements, and that is usually what only the chemistry students learn. In layman's term, basically a lot of people say H2O, but they don't really understand the symbolic representations, which don't carry any meaning unless you are studying the subject. Okay, and of course, we know that students are not very comfortable with calculations, specifically with algebra, which is to do with, not really just numbers, but rearranging terms and stuff. As I mentioned, students from lower secondary, they lack this natural aptitude, the appreciation of numbers and units. We found that not just at my school, but in fact it's been documented globally that students have problem manipulating terms and getting to find the subject of formula or expressing something as the subject of formula. And my main rationale really is if I can improve or get them to be better with this kind of algebraic accuracy, algebraic aptitudes, that this will help them with the other subjects, specifically such as physics as well as mathematics. So my research study is actually pretty small. It's kind of like classroom action research, involve my own class. This is the top set in the school, although the school is a mixed ability school. So, you get some who are at the top end, some at the lower end. Not a big class, but pretty much equal distribution. Not really equal, but, pretty much close to being equal distribution of boys and girls. So a mix, it's a co-ed school, and these students are about 14 to 15 years old, give or take. Suitable, not suitable, but in the range of this age group here. So my study design doesn't really follow the usual concept of pre and post test. Rather, it is my belief, and that we need to really assess understanding over a longer period of time rather than just, let's say, over 2 weeks or 3 weeks of a typical study design. I designed my study to be longitudinal. In fact, it's supposed to run for the whole of the 3 years of their O-level span, the 3 years normal stream rather than express stream. But then because the Teacher Day Conference came a bit early, so I had to stop collecting the data. In fact, I only had time to deal with the data up until June 2022. Then I had to come up with a proposal and stuff and started analyzing the data. But then since I have the data over 4 particular sessions, you'll see that I started introducing the topics in June, July 2021 last year. So when you first introduce a particular concept, it takes some time for it to kick in. Students learn the mole for the first time. Students learn more of the mathematics for the first time. Of course, it was always going to be difficult at first. Hence, we have corrections, we have feedback classes going through what went well, what went wrong, and how we could further improve the understanding amongst the students. And over time, as you can see, a couple of months lapsed before I kind of like tested questions of similar sorts. But there are always opportunity to assess the understanding of the concept as well as using this particular method, which I am going to show you in a little bit. And students will always inform at least a week in advance, so it's not like a surprise test. So they always had opportunities. Of course, I didn't tell them that it was going to be, there was going to be a question on moles. It's really just to get them to be on top of things and know that it's always been my style to have a little bit of previous topics which they have learned before. And if they have learned it before, it should be no problem to assess them because it is something they have learned before. As for whether they forget it or not, that is a different story, and that is not the key concept. That is not the key point of my research study. Okay, so in general, you could see that the average score by that 20 students, and I just took the average score for the class for this particular set of questions, which involve more calculations type of questions. So it's a modest improvement. In fact, it's not really like huge improvement, but we could see on average it's around 50 something, 55 to around 65, 66 like that. That was over a period of 10 months with this particular tile. You will see that it gave me this particular answer previously. I also get the exact same answer here. Now, if you are not a chemist, if you are not so interested in the chemistry background, what is the key takeaway? The key takeaway is, as a teacher, I bet that you are fed up and sick of, going through students' calculations or working. They are not clear, they are not properly labeled, they are difficult to follow. At the end of the day, you just want to look at the answer, and then, it's pretty hard to spot whether they done something wrong or not. But yeah, it does take a bit of practice for students to get used to this particular method. And as I mentioned before, certain disclaimer note, I did not come up with this method. I simply adapted some of the best practices I've seen over the years. This is an example of a student who did a topical test in September 2021. So this student was able to, replicate what I have taught in the classroom pretty well. But sometimes they still write without the shorthand notation, so they wasted a bit of time. This student is one of the strongest in the class. This student should have no problem adopting or learning the method at all. Whereas previous student also do 2 divided by the whole thing, which is weird because this is half times that. And then this student had 2 times the whole thing because this student inverted the whole thing again. So there is that problem with algebra again. It was a bit disordered. This is a student who managed to set up the mole ratio. This was in March 2022, about half a year, actually 9 months, about 8 to 9 months, I think, July 2022. So there's around half a year to 9 months like that. Since the topic was first introduced, so this student was able to set up the mole ratio, no problem. And then move up the whole thing to the other side. This student got it the other way around. So it turns out that algebra is still very much an issue because you wanted to move things step by step. So move the denominator to the other side. Don't change the 3/1. That student get the idea. But then this is on this side, so this thing should go down to the bottom. Should be the reciprocal of this, which means the other way around instead of this way around. So, this kind of thing does. Quick look. Yeah, this is a different questions, okay? So this particular questions, I'm just setting it out with the all-in-one mole ratio method. What is the key takeaway? The key takeaway is that in the all-in-one ratio method, I set it out with what I want to find, what information I have. I set it out with the mole ratio from the particular balance equations. Instead of doing ratio, I just do it as fraction because fractions, students by right should be able to do fractions better than ratio, but I could be mistaken with the students. These are just my perspective with the students which I've seen so far. What happened is that we know the correct formula for both of these is C times V. What is the key takeaway? The key takeaway is that the students is supposed to check for the units so that dividing by 1,000 will convert the C and Q to D and Q. Rearranging everything, move down the things at the bottom to the other side. This will keep the 3/1, so it's still 3/1 on this side multiplied by the denominator. As for this 45.3/1000, it's multiplied by that, so when you move it to the other side, it has to be the whole thing divided by that. Apology if this appear a little bit small, but just imagine if you have multiplication or something, it has to go down there. Part of the thing I realized with students is that when they key in their calculator, they are not very good with keying in fractions. The best thing is use bracket. by right, in hindsight, I should have put a bracket there. And students who successfully use a bracket would have a better chance of getting to the correct answer than the students who didn't use a bracket. I think my slide happened. Now, this is an example of another student. You will realize from the handwriting that these are all different students, by the way. This student successfully rearranged everything, and this student managed to get 3 marks out of 3 marks in a much shorter time compared to his or her friends. This is an interesting script. I decided to show this script because this student handwriting wrote down n equal to CV. Correct formula. C multiplied by V. This is the C, this is the V. This is divide. C divided by V is not the same as C multiplied by V. So sometimes this kind of thing happens. Students know how to write formula. They write all the formulas because they thought they would forget it. But at the end of the day, they don't follow what they have written there on the paper itself. So what actually happened there? I have no idea. So when I asked the student said she didn't know what happened on the day. Like she just thought she was doing the right thing because it looks right. But she never bothered checking what she had written down previously, and there was the incorrect use of formula. So this kind of thing does happen, all right? Now, this is another student. So these are not really problem with algebra, but I just want to highlight it while we are on this topic of mole ratio and setting it up as, all-in-one mole ratio method. This student read incorrectly. This is H3PO4, which is the phosphoric acid. Should be 1.25 at the bottom, and you're trying to find the ammonia, which is the NH3. This should be what you're trying to find. So, so that was the incorrect information. And now this student did the incorrect mathematics as well. Move up the bottom, the denominator move up. So the whole thing there. Now you have this thing multiplied by that. You're supposed to find the other one. So there is a problem with the mathematics there again. The working was wrong from the very beginning. But it's interesting to see that this student also have problem with mathematics, because by right, you should be dividing by whatever you're trying to find because you have multiplication there. So there was a bit of bad mathematics operation there. So what are some of the key takeaways that you can, that you have learned, that I have learned from this short research study with my classroom action research? So some students, they really fail to identify the correct formula, or sometimes they know the correct formula, but they don't know how to apply it because they don't consider units. I don't want to go too much into technical details, which is why I did not go through all the units and stuff, but if you are a chemistry teacher, you would know what I'm talking about. Especially if you have good background in physics, you would know that units are fundamental because these are physical units. We are talking about physical quantities. They have units, rather than mathematics, which is just numbers without any units. And of course, students have problem rearranging terms, including the use of divide or multiplication, what is moving down there, what is moving up there. And something which I didn't show you, but I also kind of did analyze it, that students kept on being confused with volume. When they see volumes in cm cubed, they thought it must be solution, or they thought it must be gas, and therefore these two have different formulas to use, therefore they end up using the wrong formula. In terms of way forward, I think it's important to actually go through some basic mathematics lessons before actually teaching more concept, and this is something that I'll adopt the next time in my next cycle, when I have a next cycle of students starting O-level chemistry all over again. So I think basic math lesson is essential. Might take some time, but at least you would be able to gauge their ability in mathematics, as for whether they're able to rearrange normal stuff or not. Getting things to subject formula is extremely important. As I mentioned, I don't buy into the idea of pre-pause immediately, within a 2 weeks or 3 weeks spent. I believe that memory retention works better a few months down the line. Therefore, it's very important to have stage practice, more like a continuous assessment, but not like immediately, maybe a few weeks, maybe a few months, even maybe throughout the course, try to assess the understanding. So a bit of summary. So I believe in my all-in-one mole ratio method. It's fast, it's simple, it's versatile. So on average, I saw an improvement in the student scores, and then with the student feedback, which I'm not showing here, but then in general, they feel confident that they could do this kind of questions with this all-in-one ratio method because they could get it really quickly, and that saved a lot of time, trying to do things bit by bit. But of course, It's not one size fits all. So some students prefer a longer method where step by step might help them a bit more. So by all means do that. But some of the better or more capable students, by all means, they can try the all-in-one ratio method. So feel free to send your questions to me if anything was unclear, because there is a time limit to this kind of presentation. So whatever I didn't manage to cover, feel free to send your questions to me if you are shy to ask questions, or you can just pose your questions to the moderator and I'll be more than happy to answer your questions. So thank you very much. So my name is Chi Sang, and that was it for my talk for this Teacher Day conference, where I talk about the mathematics in chemistry, which ended up being a double trouble. Specifically, I talk about more ratio, more calculations, where I use, instead of ratio, I set it as fractions, and we need to be able to rearrange terms to calculate exactly what we want. Okay, thank you for your attention. Have a good day. Goodbye, everyone.